Welcome. All right, so what I have here is I have y equals 45x squared plus 57x equals minus 4. And, when getting into solving quadratics, we probably, besides graphing, probably wouldn't want to do any other algebraic technique to solve except for the quadratic formula. And that's actually what we're going to do today, is go ahead by solving this by using the quadratic formula. Now, again, when I like using the quadratic formula, remember we have this in our standard form, y equals ax squared plus bx plus c. So we want to make sure our quadratic is in that format, because what we're going to do first is determine the discriminant so we can determine the types of solutions. So to determine the discriminant, we're going to have b squared minus 4 times a times c. So therefore, in this case, a lot of times what I think is also helpful is to label your a, b, and c so you don't get them mixed up, because a lot of times when you go back to the problems, you're like, oh, what was my a, what was my b? You kind of get forgotten. So a in this case is going to be 45, b in this case is 57, and c in this case is a negative 4. Therefore, now simply all I'm going to do is plug in these values to determine the discriminant. So I have 57 squared minus 4 times a, which is 45, times c, which is negative 4. All right. Now I'm going to do these individually here. So I'll have 57 squared, I don't know on the top of my head, and I will just calculate, which would be 3,249. We could obviously do this 180, 360, so that'd be positive 720, but let me just double check. Negative 4 times 45 times negative 4 is going to be a positive 720. All right, so now I'm going to add these two up, and therefore I'm going to have a discriminant of 3,969. Now, since I have a positive solution, we know that we're going to have some real solutions. We know we're going to have some real x-intercepts if we were to graph this. But are they going to be rational or irrational? So that means I need to determine, is this a square number or not? So what I'm going to do is simply take the square root of that answer, 3,969. And that is a rational root, because the square root of this is going to be plus or minus 69. So that's going to be very important. Now let's go back into the quadratic formula. So remember the quadratic formula, x equals opposite of b plus or minus the square root of our discriminant, b squared minus 4 times a times c, all over 2a. Now, what's nice about doing the discriminant is we can just plug that value in now. We can just plug that value in with the remaining b and a that we have. So x equals opposite of b, again going back to our opposite of b, which would be a negative 57, plus or minus the square root of 3,969, divided by 2 times a, which will be 90. Let me just write it in there, and then we'll simplify. 2 times 45. Okay, so now you can see I just plugged in all those numbers, and now let's go ahead and simplify to find our exact solutions. Now, as I told you, the square root of 3,969 is 63. Obviously, we already have included the positive and the negative, so I have negative 57 plus or minus 63 divided by 90. Now, again, what was so important about this is if we could not take the square root into an integer, then this would have still had two real solutions, but they would have been irrational. So again, now what I'm simply going to do is just apply for my two solutions. I'll just take x equals negative 57 plus 63 divided by 90. And then I'll take x equals negative 57 minus 63 divided by 90. So I'll complete the operations in the numerator first, and then I'll divide by 90 to get my two solutions. So I'll do negative 57 plus 63, which is obviously just going to be 6. And then divided by 90, which will be, keep that as a fraction, 1/15. So therefore, x equals 1/15, comma, and then negative 57 minus 63 divided by 90, and that's going to be negative 4/3. So if you were to go ahead and graph that, these would be your two, those are going to be your two roots where the graph is going to cross. So there you go, ladies and gentlemen. That is how you apply the quadratic formula to find your solutions. And here, where we can also verify that we have two real solutions. Thanks.